Thank you. It's an honor to be here today. I want to thank the Colorado chapter of CHIMSS as well as Prototest for seeking me out to present today. I'm a little nervous, but we'll see if we can get through this. As Pete mentioned, I work for Covidien. Covidien employs over 37,000 people worldwide. This case study is based on the Sonicision product. It was developed out of Boulder, Colorado with our surgical solutions group. I kind of want to ask the audience, those who are practicing either usability or human factors, has anybody not had a challenge with either getting people on board or just instilling methods appropriate to user-centered design? Good, okay, so that means I'm not the only one. When this project started, I was the only human factors engineer in Covidien. I was working with a team that was really quite inexperienced with human factors and usability, and actually a lot of them were what I would say misinformed. While the product may not be familiar to all of you in the audience, I'm hoping that I can convey how usability and human factors can positively impact product development, particularly in the medical device industry. So for anyone who's not familiar with the operating room environment or the surgical environment, everything in blue is sterile. There's a lot of people involved in the operating room. You have the patient, first and foremost, and then there's a surgeon. The surgeon could have an assist or multiple assists. There's a scrub nurse or a surgical tech who is usually handling all the medical instrumentation. There's an anesthesiologist in the back, I don't know if you can see him, and a circulating nurse who is not actually shown, and that person's presence is in the non-sterile field. So there's a lot of equipment, monitors, surgical kits, medical instrumentation, and the environment itself can be variable. So I already talked about the sterility, but this space is variable around the world. Different operating rooms are different sizes. Stress can be a very high stress environment at points in time. And then the temperature, the lighting, the noise, all play in the use environment here. The predicate device, which I rolled up here for the product that I'm talking about, it's an ultrasonic surgical instrument. There's a generator, I rolled it in on a cart. There's a foot pedal. If I had time, I would set it all up for you, but that would take the whole time of the presentation. But I wanted to bring that in as the example. And typically, this is in the non-sterile part of the OR, and then the circulating nurse is the person who has to set it up. And then the device itself that's used on the patient is transitioned into the sterile field. So what we wanted to do with the Sonicision device was investigate the opportunity for a cordless, so battery-powered, ultrasonic dissector for surgical use. We had to investigate the technology, so battery technology itself. We did a lot of market research. Oftentimes the term voice of customer is used, so soliciting input from all of our users who might touch the product at any point in time in a hospital facility. And we also did contextual inquiry and observations of the workflow in the current medical environment. So not only the operating room, but we also extended down to our central processing and our storage facilities in the hospital. So due to time, I kind of want to focus on the OR, specifically the procedural setup, as well as the surgical use of the device, and hopefully give you an overview of the opportunities that we were able to take on and the design considerations for the device leading to the usability of the product. So for the procedural setup, our focus was really on the scrub nurse and transitioning the circulator out of the picture. Our key points were to look at device preparation and assembly, reduce the time for the setup, have a single person be able to do the assembly, have confidence that the device was ready to use surgically. And then, so with that, we focused on the intuitiveness and the ability for the user to actually set up the device without any instruction. And then being able to troubleshoot if there was a problem. So specific design considerations that we made. First and foremost, the device connections, which were transitioning from the non-sterile environment into the sterile environment. Secondly, the number of components that we had, how we would separate the parts, and the form factor of those parts. And then how to maintain the sterility of those parts if we were deciding to use reusable components. So with that, there were decisions on the technology, the materials that we were going to use. So we went about this with multiple design iterations. We went from foam core models to SLAs to functional devices to finally the manufactured parts in our testing. We did several rounds of testing. We started out locally and then kind of grew that worldwide. We allowed the user to show us how things were done, how they would intuitively put parts together. So we'd basically say, here's all the parts, can you make it look like this? Kind of like a puzzle. We looked at difficulties and physical challenges, or the potential for them to possibly drop the equipment while they were handling it. And then with respect to the troubleshooting, we discovered what the user would instinctively try if we induced a fault for them, and then how much were they really willing to troubleshoot. And we found out that it was going to take about, they're willing to try 3 things, and that was about it. So we had to make sure the device was working after about 3 attempts. I gotta go back one. No? So for the surgical use, we particularly wanted to look at reducing the cord or the cable management in the surgical field. The space, as you can tell in the operating room from the previous pictures, it can be pretty tight, a lot of equipment in there, so we wanted to reduce the footprint. And then we were also concerned about portability and maneuverability, the ability for the surgeons with their surgical staff to be able to pass that device back and forth. We focused on the size and the weight of the device, the actual controls that the surgeon would have to interface with in order to get the device to work, the audio and visual indicators that were necessary, and then even the potential for replacing a battery mid-case if the case went really long, and troubleshooting. So this is where we kind of ended up. Actually, let me take a step back. The design considerations themselves, we looked at form factor, and this is where we brought in industrial design. Somebody had mentioned using industrial design earlier. So that was a key component to actually making the device attractive. We had to look at weight. Battery technology, when we started developing the device, it's still evolving. And so that was our biggest concern, was could we get the product in a form factor that would be acceptable to our surgeons if they had to use it for longer than an hour. Some surgeons' cases can go 8 hours in a really long case. So we engaged a surgical advisory group. It was a core set of surgeons that we had as consultants to the company, and they were worldwide. So we were able to solicit information from them from a clinical perspective and also have them do an initial weigh-in on our proposed designs and the controls that we were proposing. Excuse me. this is kind of where we landed. So we used color to distinguish between the reusable and the disposable components. So the reusable components are gray. I don't know if you guys can see that in the very back. And the disposable components are white. So with the Sonicision device, there's a reusable generator and a reusable battery. There's a disposable dissector, as well as the torque wrench for assembly. And then there's other system components to support the sterilization of the device, as well as battery charging. Key UI features of the device, so user interface features of the device. I mentioned the colors, but also the indicators. There's a speaker, small speaker built in, and then there's an LED at the top of the generator. The controls themselves for surgical use, there's a lever that the surgeon can work to open and close the jaws to clamp on tissue. There's a rotation knob, which allows 360 degrees of rotation, or infinite rotation. And then there's a dual stage button. The device can provide ultrasonic energy in 2 different modes, both min and max. And then there's additional controls for assembly and disassembly, including a battery latch and then the rear torque knob at the back. So I want to talk a little bit more in depth about the indicators, because I think this might be more applicable to a lot of the people in the room. For assembly, we had to look at that nurse and the consideration for her or him in assembling the device and knowing that the device was ready to go, so that when they hand that over to the surgeon, they have that confidence. There were more combinations of audio and visual than you can imagine. Everybody has an opinion of what the color should be, what the sound should be. So we really tried to simplify so that we could give whoever that scrub nurse or the surgical tech that confidence that they would know that the device was working. We leveraged off of what does the user need to know, and then if there was a problem, would they recognize it, and what would they do to fix the problem? So we combined audio and visual indicators. We found out that the users consistently recognized green as good and red indicated that there was a problem. So that's pretty consistent worldwide. At startup, we decided to do something kind of cute and threw in a Morse code hi as far as hello, I'm awake, we're working. And then the air tones associate with the red when there's a problem. So with the reusable components, we had to also indicate end of life. So for the generator itself, we originally wanted to have a white indicator that would be distinct from some of the other indicators that we had. However, technologically, we had a little bit of problem with the software, and we couldn't get a true white to show up. And the lighting conditions within the OR environment give a little bit different perspective of what that color could be. So what we ended up doing was just asking the users, what color does this represent? And most of the time the answer was purple, so our white had a little bit of a purple hint to it. So what we ended up doing was basically change our IFU to indicate purple, because that's what people were recognizing. So this page is actually a page from our IFU. And what I'm trying to say is that we used our testing to drive the information that we put in our IFU. So for the surgical use, what we found out was the surgeon wants the device to work always. So as best we could, we make the device work always. Audio is a primary indicator for the surgeon. The problem, or the challenge, I should say, with our device was that we had a fixed volume on our handpiece. And if you go to standards, there's a minimum level, but the standards indicate the device is actually 3 feet away, or 3 meters away, excuse me, at what's that at where that's measured. So taking into consideration you're now in the surgical field, does it really need to be that loud? So we had trade-offs there that we had to work with. We also wanted distinction, so there's no confusion. We considered orange, but the difference between orange and red is sometimes not very distinguishable. So when we got to a low battery condition and trying to figure out what to do with that, we got all sorts of feedback from the users. Make it blue, make it green flashing, make it orange, make it yellow. So what we did was we went back to the standards. Yellow means caution. Okay, we want to warn the user that the battery's going to go in a little bit. So we gave them a yellow, we gave them an audio tone, and then we gave them flashing. Because what we found was that even though we gave them the tone and we gave them a yellow indicator, they didn't always recognize it. But once we threw in the flashing, they actually did recognize it. So I'm hoping that this is going to play. I should want to play the whole thing. So that's just a demonstration of the areas that we focused on set and surgical use. I'm going to set this up really quick. While I also explain that I do believe that the human factors engineering and the usability work done on this project did lead to and aided in the value proposition. That's the setup of the device. 2 modes for energy delivery. I will also tell you that while the team was really skeptical at the beginning, this device won the 2013 MDEA Gold winner this past March for the surgical instrumentation category. And I'll leave you with a closing from the FDA and actually say that you can go beyond safety in your medical devices to really make a good product for the end users. And with that, I will thank you again. And I also want to acknowledge my Sonicision team members back at Boulder. Thank you.